Hello, welcome back to the channel. Under this section of this tutorial, we are looking at minors and cofactors of a 3 by 3 matrix. Now, when we talk of a minor, then we are referring to a value that is computed from the determinant of a square matrix, which is obtained after crossing out a row and a column corresponding to the elements under consideration. So, for example, if you are to find the minor of an element aij, then we are to delete all the elements in the ith row of that particular element, then the jth row of that particular element. So the minor of an element aij is the determinant that is obtained by deleting its ith row and jth row in which the element aij lies. So all these elements, for example, we have a 3 by 3 matrix A11, A12, A13, as well as A21, A22, A23, in that order. So when we take an element, for example, 2, and we have to find the minor of the element 2, then we need to delete all the elements, that is, element to the ith row and to the jth row of that element. So the remaining element becomes, after finding the determinant of the remaining elements of the, which is a square matrix, then we term that one as a minor of the elements 2. So I think this one is an error here, so let me cross out here. So in this question, we are to find the determinant, the minor of the element 3 in the matrix. So 3 here, this is the element under consideration. So we delete all elements in the row of 3 and in the column of 3. So the remaining elements, which is 2 and 0, 2, 0 here, and then 7, 1, 7, 1, then we find their determinant. So 2 times 1 minus 0 times 7. So 2 times 1 is 2 minus 0, which is 2. So 2 becomes the minor of the elements of that particular 3 under consideration. So now let's take another question. Let's find the minor of the element. Let's find the minor of the element 2. So this is the element under consideration. So we delete all entries to the row or the ith row of the 2, which is this, and to the jth row of 2. So we will have 7, 1, 3, 2. So let's find the determinant. So 7 times 2 minus 3 times 1. So 7 to 14, 3 times 1 is 3. Final answer becomes 11. So the minor of the element 2 in the matrix, this one is 11. So in this way, all elements here we can find their cofactors. That's great. So now let's talk about, sorry, they are minors. Now let's talk about the cofactor. So we can form a determinant of these elements, but the rule under consideration or the appropriate signs are given by plus, minus, plus, as we saw in our previous discussion, minus, plus, minus, plus, minus, plus. So these are the rules under consideration. So plus, minus, plus, minus, plus, minus, plus, minus, plus. Great. Now let's look at how to find a cofactor. So as I said earlier on, the appropriate place signs are given by this plus, minus, plus, minus, plus, minus, plus, minus, plus, and the alternate plus and minus from the top left hand corner, which carries a plus. So in this case, if you have to find a cofactor of this element, then we need to target the minus first. So in this case, our cofactor is giving us, so we are targeting the first one is C11. So C11, The formula for finding the cofactor of an element is given by -1, the I plus J, and then our minor. Good, times our minor. So in this case, we are going to have, the question says we should find all the cofactors of A. Find all the cofactors of A. So we will start with first one, which is C11. So our C11 equals to -1, and then the first row is, which is the same as A11. So you have here our row is 1, our column is also 1. Then the first row, the first column. So now let's go. What's the first row, first column element? So this is the one. So you delete all entries to the row of that element and to the column of that. So it will be left with 7, 1, 3, 2. Find their determinants. Okay. So we will have 7. So we will have 7 times 2 minus 3 times 1, which gives us 7 to 14 minus 3, which is what? 11. Okay, now let's find the next one. So we can find all the cofactors of this element. Let's pick another element. Let's say we have the second element, which is -2. So we are going to have C1, 2, -1, 1 plus 2. This one too is 1, 2. So we are going to have, if the root is plus minus plus, so this one I'm going to have negative. For the first one was plus, so we delete all entries to the row of -2, so into the column, so it will be left with 0, 1, 4, 2. So 0, 1, 4, 2. So we are going to get 2 times 0 minus 4 times 1. 2 times 0 is 0, 4 times 1 is 4, so we have -4. So it means that the next one is going to be plus, which is C1, 3. So we have -1, 1 plus 3, M1, 3. So plus minus plus, so is equal to plus. So the next element is 7. So we delete all elements to the row, that column. So we have 0, 7, then you have 4, 3. So 0 times 3 is 0 times 3 minus 4 times 7. So 0 times 3 is 0, 4 times 7 is 28. So we have -20. So we can find all the cofactors of the elements in this particular matrix. Wait, now let's talk about adjoints of a matrix. Now before you find the adjoints of a matrix, then you need to determine the cofactors and the transpose of that particular matrix. So before you find the adjoints of a matrix, then the first step is determine the cofactors of all the elements. Then you find their transpose before you find the adjoints. So great. Now let's look at this particular question. So here we have our matrix B as 2, -2, 7, 0, 7, 1, 4, 3, 2. The first thing, as I said earlier on, is to find our cofactors. Determine the cofactors. So here we pick 2. So you have plus, as I said, the target element is 2. So these are all deleted, these are all deleted. So you have 7, 1. You have 7, 1, and then 3, 2. This one too you have. So this one gives us 7 times 2 is 14 minus 3 times 1, which is what? 11. We take the next one. So this is B11. So let's call this one as our B11 or A11. So this is our A11. Let's pick our A12, which is -2. So we are going to have, this is plus minus plus. So do not forget this. So we are going to have this one as our target element. In this case, this. So we have all the elements in the row deleted, this one to be deleted. So you have 0412. So 0412, and then we have negative bracket 0 times 2 is 0 minus 1 times 4 is 4. So negative times positive, negative times negative gives us 4. Then you have A13. So plus minus plus. So this one too, the next one is 7. All rows element to the target element 7 and all column element to the target of 7. So it will be left with this 0743. So 0743. Let's find the determinant. This is equal to 0 times 3 is 0. 4 times 7 is 28. So the final answer is -28. Great. Now let's find A21. Now we are here. So we delete all elements here in this one. So we left with 2732. Great. So -2732. Now let's find the determinant. So this is plus, because we are here, plus minus plus minus, sorry. So this one will be minus. Sorry. So this one will be minus. Great. So minus into bracket. -2 times 2 is -4. 3 times 7 is 21. This one is -25. This one is +25. Now let's check this A22. Okay, so A22, we are here. So all elements to the row of 7 into the column part of 7. So delete this, delete that. So we have 2742. So 2, this is plus. So 2742. Now let's find the determinant. So 2 times 4, 2 is 4, 4, 7, 28. So -24. Now let's find A23, which is this. So we are now on minus plus minus. So we have minus into brackets. So we are here. All entries in the row column. So we have 2 -2, then 4, 3. So we have negative into bracket 2 times 3 is 6. 4 times -2 is 8. Sorry, -8, because it's already minus. So -6 into bracket +8, and that gives us -14. Now we come to A31. So we are here. A31 equals, delete all entries to the row of 4 and to the column of 4. So we left with -27. So this is minus plus minus plus. So plus minus plus. So we are using the rule to solve this question. So we have 2071. So we have 2 times 1 is 2, 0 times 7 is 0. Okay, now let's find A32. So let's go back here. A32 is this. So all elements to the row into the column of 3. So we left with 2701. So this is minus. Yes, so we are on the second one. So we have 2071. 2071. Sorry, 2071. So you have negative. The bracket 2 times 1 is 2, 0 times 7 is 0. So you have negative 2. And then the last one is 2, which is A33, and that is 2. So all elements to the row of 2 and all elements to the column of 2. So we have 2, 0, 2, 0, 2, 0, negative 2, 7. 2, 0, negative 2, 7. So 2, 7, 14 minus, this is plus, minus plus. So we have 2 times negative, 2 times 7, 14, 0 times negative 2 is 0. So you get 14. So the next thing is to find, so we are done with the cofactors of all the elements in the matrix. And so the transpose of the matrix can now be found. Now let's look at this question. How to find the transpose of this particular matrix. Wait. So we have our first element as 11, 4, 4, negative 28, and then we have the next one is 25, negative 24, then we have negative 14, negative 14, and then we have 2, and then here too we have negative 2, and then this one too we have 14. So these are the results of the cofactors. Wait, now let me clear all these things and then write them in the matrix form. Okay, so let me clear all these. Okay, so let me clean all these two left spaces for these things. Okay, so let me clear all these to have a space for